Okay, there's no way of knowing. Okay, fine. So what equation did we do the last class? We started refraction, correct? Okay, so we have started refraction, that's correct. Okay, fine. I'll start writing from here. Maybe that will help. Or maybe the. Okay. So we started with the refraction. We went through certain ray diagrams. Do you remember that? Do you remember the ray diagrams we did in the last class? We said that they are slightly different from the mirror. Okay, the equation, I mean, the ray diagrams are slightly different than the mirror. We have done this, I believe. Pretty sure we have done this. If you can go to page number 181. See, it's right here. So we have done this. Correct? You just go back, refresh your memory. I prefer that you read and go through stuff before you come so that there's continuity and you remember things. So we have gone through the rules for the ray diagram and I asked you to try out these. Right? I'll tell you what page it is now. The next page. Next page. Next. Yeah, next. No, next. Yeah, so those are the diagrams. These rules we have gone through and I had asked you to do the ray diagrams by yourself because there's nothing new in it that you do not know. Do you remember that? It's kind of. Okay, guys, it's always good to go home and revise things. Guys, can you hear me? Guys who are online, if you are online, can you please, and if you can hear me well, can you put a thumbs up in the chat box? That's what it says, but that's what it was saying by default. But I don't know if I'm connected online through this or through this. I think I'm speaking into this and the mic here is on. I'm not sure. That's what I believe. Guys, if you can hear me, see, this one is unmuted. Guys, if you can hear me, can you put a thumbs up in the chat box? Okay. See? Okay, fine. Alright. So, these diagrams we went through in the last class and that's why I will not repeat them again. You know all of this. We did it in the last class. Okay? Again, it will take time to go through it again. You read it, you'll know it. I'm pretty confident. And we looked at the lens makers, the lenses formula for the lenses. We wrote down that equation and we said that the only thing that changes is what? The sign. It will be 1 by v minus 1 by u is equal to 1 by f. We have done this in the last class. You remember, this comes after the previous one. Okay? And again, the magnification curve formula changes. It becomes h dash by h. In previously it was v by u, or here I believe it becomes minus v by u. No, previously it was minus v by u, or here it becomes v by u. Okay, it's pretty straightforward. Okay, so hanged on this, there's just one last portion that is remaining in your this one. It's called the power of the lens. Okay, it's called the power of the lens. Okay, the power is nothing but it tells you understand, right, what power is? It's a very straightforward thing. It tells us by how much a mirror or a lens is diverging or converging. Okay, by how much. Okay, so I'll know if I know the focal length, it is 1 by f is the power. It's a very straightforward relationship. So in some of your questions, in some of your numericals, when they are asking you, Bhaskar, can they hear me? Can the participants hear me? Okay, because they are not responding. I've asked them to, if they can hear me, I've asked them to send me a thumbs up in the chat box, but I can't They are not responding in any way.
Kaushik? Kaushik, can you hear me? Are you getting finished? Yes, sir. Yeah.
Hari, can you hear us?
Yes, sir.
Okay,
Kaushik.
cool. Yeah, okay. Okay, then mute your mics. Okay. Okay, so according to the F, the amount of convergence divergence changes and hence the power changes. Okay, another way of saying I want a mirror of focal length this is saying I want a mirror of power this. It's just 1 by this one. You understood this, right? Is this clear? You look confused to me? Were you there the last class? You were there. You are the new student who came last class. Is it clear to you? Okay. See, we having known this, we'll move on to the next unit. What is the next unit? Which one? Sign convention for spherical mirrors is the same. See, for lenses we follow sign convention similar to the one used in the spherical mirrors. We apply the rules, everything except the measurement taken from the optical center. According to the convention, the focal length is positive and that of the concave lens is negative. The focal length of the so the only change that comes is that the focal length of the convex mirror is convex lens is taken positive and that of the concave mirror is taken negative. Yeah, the rest of the things are same. Nothing changes. That's why I didn't try and do it again. Is this much clear to you? I don't want you to be confused. That's it, no? Okay, move on to the next chapter. Okay, can you close your textbook? Hmm? What? One diopter must be 1 minute. Do you have a different textbook than I do? Because as far as I remember, this question never came anywhere. I believe that is just a standard unit of measurement. If you go through the textbook, you should be able to find these things. Okay? If you still don't find it, you just let me know in the next class. Is that fine? Okay? Because I want to rush through it. Whatever is necessary for a basic understanding. No, see, the thing is, my point are here is to make you understand the concepts. The proper definition, what is power? It is the blah 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 blah, or it is the quantity by which whatever has to be measured, blah blah blah. That definitions you'll either find in the textbook or your teacher will give you in the notes. Main issue here is that you should understand the concept because I'm not bothered about the words you use. Your teacher is bothered about that. That's what you will learn from the textbook or from the notes. If you still want stuff like that, we can figure it out, okay? That's why I even don't give you notes. My main aim is that you should understand the concept. The concepts are clear, no? So even when you read those definitions, you'll be able to understand it and remember it. Is that correct? Okay. So we'll move on to the next topic very quickly. And the next chapter, if you can go through this chapter, I'll give you a couple of assignments, maybe. I'll ask them, or we can have a test. That way we'll know if you do not understand a particular concept, you can always revisit it. And we can have a discussion. Is that fine? All good? Okay. So close your textbooks. We'll look into the human eye. Okay. So, okay, I don't think maybe they have the images of this. Let's hope. Tell me. Okay. What is refractive index? Okay, so they have kept it here. Bhaskar, can I have the slides for the next topic, next unit? This unit is done. Yeah, chapter 2. Yeah. I'll answer your question. Okay, I'll answer it right now. So the thing is, when it comes to an optical property of a material, it becomes very important to define it. Okay. Now, for example, with human beings, we have, if I want to look at the physical property of a person, I'll say I can check the weight or I can check the height. That is the physical property of the person. Correct? But it is not telling me anything about the smartness of the person. It's not telling me, you okay? It's not telling me anything about the emotional state of a person. It's not telling me nothing about the age of the person. Correct? No? It is what? It is only a physical property which is telling me either he is heavy or not, that is weight, and height, which is telling me how tall he is. It is just one type of a property of a person. Correct? Now I can have a material and it can have many types of properties. It can have toughness, it may have strength, it may be malleable, it can be conducting, meaning electricity can pass through it, or maybe electricity will not pass through it. It's, human eye and colorful world. Okay. Yeah. So that is the different types of properties of a material. But now I want a material that I want to use for an optical setting, meaning I want to pass light through it. So this is where I need to define some property that I can measure of a material, which is same for that material but is different from other materials. Wood and glass will not have the same property. I want some kind of a property like that tells me something about how light will pass through it. So that's where I define a property. It is a defined property called refractive index, okay, which is given by, now what can I measure in an optical material? There are different things I can measure. But if I am interested particularly to know how the speed of light changes in a material, I use a property called refractive index, which is given by C by V. C is the speed of light, which is a constant everywhere. V is the speed of light inside that material. So that way, for every material, if it's glass, it will give me a particular value, maybe 1.4, 1.5. If it's air, it may give me 1.1, 1.2. So the refractive index of a material is that optical property, which will tell me how fast the light will travel through it. And there are some advantages to knowing refractive index, because there are certain things we can define with that. Are you getting it? Using refractive index, we can do a lot of very interesting things. One of those things is called total internal reflection, which we will look into in this chapter. Clear? Have I answered your doubt? Okay. Forgive me, I am just not healthy. Let's see. Okay, they have not put that diagram over here.
Only empty slides.
Oh, plain slides, huh? So the thing is, I want to show them this picture. If I okay. Anyway, you know what we'll do? You open your textbook, you can see the picture in front of you. It's better than me drawing it. Are you okay with this approach of teaching, or do you want me to change anything? You can let me know anytime. That way I will know, right? Okay, page number 187. Yeah. So do you see a picture of eye in front of you? Yeah. So one of the most complicated things biologically to exist is the human eye. And that's how we sometimes draw inspiration from biological things to make an invention, right? So the human eye is one of those things that we take inspiration from to develop cameras and things like that. And in fact, till date, we do not fully understand how we are capable of doing something so complex. Can you imagine? You are looking at me. Light is coming from me to you. It is not two-dimensional, it is three-dimensional. You are able to determine my shape. You are able to hear me at the same time that I am speaking to you. And it's all connecting. Is my voice lagging? Lagging? Is my voice going behind and my pictures coming fast? No. It's piecing it perfectly. So that's something very beautiful about the human eye or the biology in general. Okay? And what we'll do is, see, drawing this will take time and it is unnecessary. You can see it right in front of you. So this is the human eye that we can see right in front of us. Okay, and now what you saw in your previous unit was that in order for me to image something, for me to take an image of something, I need two things. I need an object, obviously. I need a lens or something, some kind of a medium. and that has to be focused, and I need a screen to capture it. If there is no screen, the light is just going, right? Are you late for something? Am I? No, right? Okay. So you're checking the time and all. I thought. No problem. Sorry. I'm so sorry. Okay. So the thing is, we need a screen to be able to capture the image of the object. Okay. And the thing about the human eye is, we have these components. Do you see something called the retina over there? Yeah. So the retina acts like a screen. Okay. So the light will fall on this screen, and that is through the retina. And do you see something called the crystalline lens, which is in between? Yeah. So that is the lens which is actually there in our eye, which is very strange, Till now you are learning about lenses, but did you know there is a lens inside your eye? Yeah. So there is a lens inside our eye. So this lens will take the image of whatever we are seeing, and it will focus it where? On the retina. Okay. Retina is the screen. Alright. So the thing about these crystalline lenses is, now the thing is, everything is not the same size. Remember last time we discussed about how if the object is very far away at infinity, the image is focused on the focus. If the object comes closer, the focus change, the distance of the focus changes where the image is formed. Accordingly, according to the position of the object, where the image is formed, it changes. It's not always at the same spot. Correct? Remember, we drew a few diagrams. It was either here, it was here, it was here, it was on the other side. The image position keeps changing. So what happens is, we will need a lens of different focal length each time. Isn't that true? If one type of a lens is focusing the image here, we need a different type of a lens that can focus a image maybe a little closer or very close. Correct? But can we keep different lenses on our eye? That's not possible. So because we have one lens, so now the shape of the lens has to change. So this job is done by what we call the capillary muscles. Do you see that? Or there in the image? Capillary muscles. Yeah, there are two muscles which are controlling the top and the bottom portion. So what will happen is, now see, this is the lens of your eye. Okay, the objectives are here. This is a man, let's say. Okay, the image of this man will come from infinity, and it will focus here on the focus, and this is where your retina will come, which acts like the screen. Okay, are you understood? If the man comes closer to you, what will happen is, the capillary muscles will push this lens in such a way that the lens will maybe become more round, and it will still focus it on the retina. Otherwise the image should have shifted. So according to the distance between the object and the lens, the shape of the lens is being changed, so that the focal point falls here or there, always on the retina. Okay. Now apart from this, we have a pupil. Okay, that is the part that we see, the black color thing. We have iris. The iris is the colored part that we see around the around the pupil. And then we have an aqueous humor, which is basically a bunch of liquid which is there, and it also acts like a lens, but not to that extent. Okay. So yeah, so most of the refraction, it says here, of the light rays coming to the eye occurs at the outer surface of the cornea. Okay, at the outermost surface. So what will happen is, there's another thing that we want to look at, and that is how much light is coming into our eye. If you are looking at the sun, not only will your eyes shut down, the part which is there, the colored part, it either becomes big or it becomes small. Have you seen those cameras where they can change the size of the shutter? They do like this, and it's either very small hole or this hole becomes bigger. So they want to control how much light can enter the system. Maybe you're looking at something very bright, there's already enough light. So what your eye will do is automatically, hey, I want to make the size of the hole smaller so that less light goes into his eye, because it's very bright and too much light maybe it can spoil your eye. Okay, that's why parents say do not sit in front of TV or in front of your laptop or on your phone all day. Your eye may get spoiled. Why? Because there's so much light that is coming, that is hitting your eye. You know, every time your lens has to be working on adjusting. Every time your this one iris has to get bigger or smaller. So it is this iris that you can see in your textbook. That iris, the colored part of your eye, which either becomes bigger or it becomes smaller, and accordingly it allows how much light should fall on to the retina. Is that much clear? Okay. So now because we are human beings, there can be us, and then see there is this optic nerve. Everything is converted into electrical signals, and that electric signal is sent to the brain and it is processed there. Now the interesting thing is the image which actually forms on the retina always is upside down in nature. Okay, and your brain actually corrects that image and it does all this process very beautifully. Okay, so now the problem is that and see, this is called the nature of the eye. So what is happening? The lens shape is changing all the time. So what it will change? Its focal length will change, and we realize that power is 1 by f. So if the focal length is always changing, the power of the lens is always changing. So this particular property of this lens to keep changing its power is called the power of accumulation. It is there on your next page. Okay, so it can either become thin or it can become thick, and this is called the power of accumulation. Okay, but the interesting thing is that there is a certain limit below which the lens cannot change its shape. Okay, can you keep this thing in front of you? Okay, I want you to do one exercise. Take your pen or pencil, look at its tip, and see how close you can bring it to your eye while retaining the perfect image of the pen, as in it should not be blurred. So see how close you can bring without it being blurred. What is the how close? It should not be blurred. The moment it starts getting blurred, you stop. How? Is there a point after which it becomes blurred? Yep. No? You are able to see perfectly. So the thing is, or what you can do is you can bring your textbook close to you, and you can see at what distance the alphabets, they don't look like perfect alphabets. You can do that. Maybe you can read it, you can make out, but it's not clear. It's not 100% clear. Clarity decreases. Okay. So the distance generally is 25 centimeter, below which any kind of any image, it cannot be resolved properly. It's called resolution. As in, you will see if there are 2 points which are very close, from far you may be able to see them very perfectly, but the moment you get very close, you cannot resolve them as 2 points. It becomes very blurry. So this is called the least distance of distinct vision. Okay, what is it called? Least distance of distinct vision. Okay, you guys had a very heavy lunch, I think, every one of you. All right, is that fine? Least distance of distinct vision. And there is another one similarly for farther points. When we go further and further, there are things that we cannot see. It is called the far point of the eye. Okay, means things that are so far you cannot see them. Can you see a planet? No. Why? Because it is beyond your far point. You cannot comprehend it as a two different thing. Okay. Now the thing is, your lens, which is there, it can get, so have you seen old people whose lenses eyes have become milky? Have you not seen cataract? Have you heard of cataract? Okay, so when people get old, let me check. When people get old, a lot of people in our country at least, it's not connecting me to the internet. When people get old, they develop, what happens is the lens is there, no? It becomes melty and it becomes cloudy. It starts looking like milk. Let me show you. Have you seen people whose eyes have become like this? Generally happens to old people. It becomes slightly whitish. So that is called cataract, and there is a surgery for it, wherein it's a kind of a disease, yeah. Not a disease really, you can call it a disease, yeah. No. Some people, even when they're 100, their eyes are perfectly fine. But some people, they may get cataract, and then there is a surgery for it where they remove your lens and put a new lens. Okay, yeah. Yeah, their seeing depends on the degree of it. So it starts reducing. It's like a wound. If it's worse, it is worse. So if the cataract is worse, your vision becomes impaired. Okay. So now the thing is, see, we as human beings, you can close your book maybe for this one. Okay. So what will happen is, sometimes now our lens does not, like all things, our lens may not work, the lens of our eye may not work perfectly. Okay, I am one such a case. Okay, so what may happen is, now, okay, yeah, so my lens may not deform enough to focus the light on the retina. My retinas are here, but the image is being formed in front of the retina. This is the entire eye, okay? Understood, no? So my image is formed not on the retina, but before the retina. So such a condition is called myopia. Myopia, that's all. Okay? Yeah, that's what you also have when you take off your glasses. Okay? So what we both have is myopia. Okay? And then we can solve this. How do we solve this? We both are wearing the solution. What is the solution? It's glasses. So what we do is, very interestingly, the image is not forming on the retina, it's forming before the retina. So we want to shift the focal length. Okay, understanding? I want to shift the focal length enough so that the image is formed on the retina. Only then my brain can get the image properly. Hmm? Yeah, so I'll get you to this. So in the last class and last to last class, I don't know if you guys remember, we discussed that there are two types of lenses. This one is called what is this lens called, man? Concave. There's a cave inside. Yeah, okay, it's a concave lens, and this is a convex lens. So this lens, the convex lens, is called the focusing lens also. Okay, and this is called the diverging lens. So the job of the diverging lens is, if the light comes now, it will get diverged. Okay, it will go away. Understood? Okay, and the job of the focusing lens, or we can even call it the converging lens, is that it will focus the light closer. So what we do is, this is our lens, this is the light, it's forming here, but the retina is here. So what type of lens will I put over there? Convex or concave? I'll put a concave because it is diverging. If I put this, it will spread it out a little so that the focus is formed here, this both combination. Con convex lens, concave, no, this is the concave one. It diverges. This one diverges only. This one does not diverge. This one always focuses. This is the lens. Check in your book. Don't be in doubt. Okay, maybe the teacher confused you, but is it correct when you look at the book? Don't believe anything the teachers say. We may be wrong. Is it correct? Huh? No, is the book correct? So this is correct? Satisfied? Okay, now we'll continue. Okay. So now you have understood. If you look at the shape of this one, you get to know, man. Understood now? This kind of lens, it is round, it will come like this. This kind of lens, it will spread it out. Is this much clear? Or a better way to show it is, this is my, I'm going to take a concave lens. Okay, light will come like this. It will spread out now. Okay, from here it came, laptop. Okay, okay. So it will spread out now. Now it will focus this again, and it will fall on the retina. Is this clear to you? So I am going to add this lens, and that is what we are wearing. Okay, we are wearing the
Like some people cannot see when the object is near to them.
Yeah. So we are coming to that. So this is called myopia. The one you are talking about is called hypermetropia. Okay. So there it is exactly the opposite case. Your lens is not supposed to change, is not able to become thinner. So now let's say there is an object which is very close to the eye. Okay. So here it will again focus it. Here is the retina, but it focuses it behind the retina. So it is not forming again on the screen, it is forming away from the screen. It is forming behind the screen. You able to understand? So this is when there are people who cannot, there is an object closer to them. It's called farsightedness. The previous one, which is called myopia is called it's called nearsightedness. Nearsightedness means I can see what is near. Nearsighted, I can see near. Far, I am not able to see. Okay, this is called myopia. The second case is called hypermetropia, which is also called long-sightedness. Means I can see what is far. Long I can see, but near I am not able to see. So this is the condition you are talking about.
The people have this problem also on cave lens.
So here what we want, we don't want it to diverge and go further. We want it to come closer. So we will use a focusing lens. We will use a convex lens. Meaning there will be one more which is added, I mean behind it. You cannot put it inside the eye, obviously it's a glass. So it will focus it like this. Understood? Okay. Is this much clear to you guys? Okay. Any doubts about this? Actually, then there is one more which is called presbyopia, which is where a person, you must have seen old people, they cannot see far also, they cannot see near also. They have both of these conditions, meaning their lens is not cooperating quite well in both of these focal ranges. So what they'll do, you must have seen old people, their lens will be there, it will be of one shape, and down it will be a different shape. Have you seen that? Okay. Your grandfather and all, they have very good eyes, huh? So these glasses sometimes they look like this, not like this, in two different colors. No, the shape will be slightly different at the bottom. So what they'll do is when they want to read a newspaper, they'll down it will be a convex lens. So closer things they can see, but further things it will be a convex lens. Sorry, concave lens, right? So that they can see the farther things around here. If they want to read, the down part will be a different refractive or different focal length. Understood?
For the people who have that, without putting the glasses, where will their vision go without the retina?
Without the what type of vision will they see? So it will be like us only. Now, for example, you cannot see for things. I'm assuming, right? It becomes blurry for you. It is the same situation for me also. Okay, but the people who have the other one, hypermetropia, those people when things are come closer, that becomes blurry. So now these old people who have both, or anybody who has both, for them it is the case when things are too close also, when it is too far also.
Like I'm asking for the people who have short
Mm-hmm.
vision, you put a lens and retina and you show where the object will reflect.
Mm.
For the people who have both the short vision and long vision, where will the object like focus on?
Oh, so it is a combination of both. So what will happen is when the object is 1 minute. Where did I got this? So what will happen to those people is when something is very far away, the light from far, it is focused here and the retina is here. And for the same people, when there is an object which is close, the light will fall and it will focus away from the retina. So both is not being achieved because the lens is always changing its shape. It is not fixed. My eye will one time become like this when I am looking far. Then next moment when I am looking at something close, in a fraction of a second it will change its shape. You will not realize. Okay, understood? Same lens is doing this. So the problem with this kind of a person is that the amount of stretching which is required for this to do happen, the lens is not able to give him that. Maybe that's why we call power -1, -2, -3 and all. Meaning for me, maybe if it is -1, things that are till here my lens is able to stretch, but beyond that it is not able to stretch. Sorry, it's the other way. If the person is standing very far, his vision will be like okay. But if it's -2, it is slightly becoming bad. If it's -5, -6, it means even if the person is very close, from this point only my lens is not able to stretch beyond the point to accommodate all these people. Okay, so if its power is high, we say power is high, power 1 by f. Understood? What do we say? What is high? Power is high. Meaning focal length required is high. He needs high focal length ka glasses. That's when he will be able to focus it. Understood the word now? Power is high and all. Okay. So yeah. So and the other way, for a person who cannot see nearby things, there is also +1, +2, +3 and all of that. Meaning how closer before, after which his eye is not able to focus. So maybe there is one range, maybe up to 10 meter, where both of these functions are working very fine for him. Let's say normal eyesight will be 25 centimeter, right? Least distance. So maybe this person's least distance is 50 centimeter. Beyond that it becomes blur. And his maximum distance is only 10 meter, 20 meter. Beyond that it's not able to stretch. So that's why we use a lens that has both kinds of things, glasses. Okay. Any more doubts? Any more questions? Can I move ahead? Okay. Okay. So now, the thing is, we are going to look at the refraction of light through a prism. Okay, do you know what refraction is? What is refraction? Refraction, we talked about it in the last class. That's why I always go back and read. You are going to forget otherwise. Okay, how easily it is entering your mind, no, that easily it will come out. Okay. What is refraction? Not reflection, refraction. We are talking about materials. Reflection is one thing, Refraction is another thing. You guys even nicely told me the laws of refraction the last time. That time you guys remembered. Okay. So the thing is, you should always go back and study. Promise me that, otherwise you are going to forget it. So the refraction is that when light moves from one medium to another, the speed of light changes, because of which the light bends. Okay. If this is my medium 1, this is my medium 2, light will come like this. It should have gone like this, but it may bend like this. Okay, because the speed of light in the medium changes. Okay, and one interesting thing is, when it goes from a rarer medium to a denser medium, if this is the normal, okay, it is coming from medium 1, meaning this is maybe air. All of this is air. Rarer means it is like not thick, it is very dilute. Rarer medium, it is going to dense, something that is more dense than this, that is like water. I can say air and water. So it will always move towards the normal. The bending will be closer to the normal. But in the case, if it is moving from a denser to rarer medium, it will move away from the normal. Okay, two things. Denser, if it is moving to denser, it will move towards the normal. Okay, you can always imagine as this is more heavy, so it will try to come down. This is more light, so it will try to move away. Simple. Remember these things, like this you will not. After 1 week you won't remember anything. Okay. So there is one very interesting kind of a material, and very interesting, don't worry, I will not take much of your time. In some time we will try to wind up. Okay, there is one very interesting kind of an object that people have created. It is called a prism. Have you heard of a prism? Have you seen a prism? Okay, we have a lot of prisms back in our lab. So this object is called a prism. It's a glass which looks like a triangle. It is like a pyramid. It is a triangle on all sides. Okay, so that is called a prism. And the interesting about this prism is, so what will happen is, basically we'll try to see how light propagates inside a prism. If I take this prism and I pass light from here, then which will be the normal? The normal to the surface is going to look like this. Correct, no? So now it is going from air and it is going to glass. Correct, no? So the light should move, it's going from rarer to denser. So will the light move towards the normal or away from the normal? It will move towards the normal. Correct? Ideally, after going here, light should have gone like this, straight. It should have. But here refraction is happening, so it will move towards the normal. Okay? So the light went like this, A, B it went. From B to C, it's going inside the material. Now at C, again what is happening is, there is an interface. Here it is glass, here it is air. It is coming out of air. Okay? So you understand, no? One glass object it is. I am passing light through it. Okay? So what will happen is, the light when it comes out, now it is going from denser to rarer medium. So again, if I draw a normal here, it is going to a rarer medium. So will it move towards the normal or away from the normal? Away from the normal. So it will go away like this. Okay? So this kind of an object is called a prism. Now you might be thinking, why is this very important? Right? Why is this object important? It is, light is just passing like that. Why should we study about this? That might be the questions in your head. So the interesting thing is, see, what is white light made up of? What is white light made up of? White colored light. You may not understand this question also. You're like, why is this mad fellow asking me this? Anybody knows? I'll try to find a video to show you. Let's see. I wanted to show you this in person. Okay, let's just see this.
మేము అదృష్టత చెప్పను జియో సినిమాలు
I continue to experiment and explore new colors with my children. Today we discussed what the color white is. In order to understand why we see the color white and blue, I talk with the stranger level.
See, this person, she takes a circle and she paints 7 different colors on it. Okay. Okay. Where does she show you? Okay. So the thing is, when he is rotating it, what color does it seem to be? Huh? Next now, is it starting to look like it's white? Huh? So it's very interesting, right? That when you are mixing these colors, 7 colors together, and you're doing this thing very fast, it is starting to look like white. So the reality is, this may be shocking, that white light is not white in color, and white light actually has many different colors in it. Okay, are you able to understand this? Okay, so in fact, even the light which is given by the sun is not red in color, it is white. But when we look at it from here, it looks like it is red. Why does it look red? How do we see rainbows? So the thing is that, see, the sun, the white light has a combination of 7 colors. Okay. This is the light which is given out by the sun. So sun will give us white color light. Okay. And this 7 colors, it will be like, have you seen the rainbow? No? It starts from blue and it goes towards red. Okay. Two extreme corners in a rainbow. So what will happen is, the clouds and the sky, they have particles which are the size of this, there's something called wavelength of blue color side, and it will scatter this blue color light, and that's why the sky will appear blue. And which part is remaining? The red side is remaining of the white light, which will come to us, and when we see, it looks like it is red. Sun is red and the sky looks blue. But is sky blue? Why is it blue? Why it has to be blue? It's not blue. It's just the particles is scattering the blue color light. Okay. Other space has any color or what? No. Why should our sky have color? Are you clear about this? So now the interesting thing is, all of these 7 colors, they experience a different refractive index. Meaning, if I am blue color light, my speed is same, c 3 into 10 to the power 8 meter per second. That is the speed of light everywhere. But if I travel in a medium, again the speed of light in the medium should change. Speed of light in every medium is not same. In water it is different, in air it is different, in oil it will be different. Thicker the material, more denser it is. So the refractive index changes. The light becomes slower in thicker materials. Okay. But now white is not made out of one type of light. Light is not made out of one type of light. It is made out of 7 different types of light. And all of those light, different colors, they respond to the material in a different way. Meaning, if blue light has the speed 3 into 10 to the power 8 meter per second in air, When it gets inside water, its speed may become 290. Okay, but the speed of the red may become 280. It is not the same for red and blue. Understood? One is changing more, another is changing less. Okay, so now that is where the prism comes in, and something very interesting happens. I take a prism. Okay, first I'm going to shine in blue light, I'm going to shine white light. Okay, now the moment white colored light goes into this, this is the normal. Okay, the light must bend, but what will happen is the blue will bend more towards the normal than the red. So blue will bend towards the normal, red will move little away from the normal. Understood? Are you understanding this? Because both of these colors will not behave in the same way. So now I move, it will go. Again there is a normal, correct? Okay, from denser to rarer it will move away from the normal. So it should ideally go like this, but it is going away from the normal, so it will go like this. Okay, and if I take a screen art here, I'll get blue down, this will move towards the normal. Okay, it will, this slightly exaggeration. I'll get red R here, and in the middle I'll get all types of colors from red to blue, which is shown on your first page. No, turn, close the book. See that one small picture? Okay, so that is what it does. Is this interesting? Are you hearing about this for the first time? It will spread the light like this. This is called a prism. Okay, I think it was Thomas Alva Edison who found about this effect. So we can see which light is going inside, white colored light, and which light is coming out, the 7 colors are coming out. And the same thing is what, and this process of spreading of colors is called dispersion, the dispersion of light. Okay, dispersion of white light. Now also one more interesting thing that you can do, not necessary, is I can place one prism like this, I can place one prism like this. Okay, I'll keep them very close to each other. So what will happen is this will spread out, this will spread out, but here they will come together. So in the middle there is spreading out, here it is coming together as it is. Okay, understood now? Simple, right? Okay, so this is how our rainbows are formed. Okay, but what will act as a prism? Clouds, huh? What did you say? Sky and the clouds. Okay, what do you think? What is acting as a prism? Let me give you a clue. Usually when do you see a rainbow? Rainbow, during the rain. So what is in the rain? Water. So water acts as a prism. Yes, this is the beauty of it. So when there is rain, there is a water droplet, lights, sunlight will go into it, or whatever light goes into it, white light goes into it. Okay, and what will happen are here is it goes inside, and there is one very interesting phenomena that happens, and we'll talk about it in a while. Okay, this may is another thing that will blow your mind. So here white light, it spreads into 2. Here is the normal. It spreads into 2. It spreads into, I think, 1 minute. The lowest color is usually blue. It spreads into blue and red. Blue will move away from the normal. It goes slightly down. Red goes slightly up. will go here, and this is again, there is a process. I'll tell you about it. It will spread further, and you have your rainbow. Okay, so you must be wondering why it is coming back from here. Okay, so there is one more process, which is the most beautiful process of all, which is called total internal reflection. Okay, I wish I had the props to show you, man, because sometimes we carry some things, we can show you the total internal reflection line. So just the thing is, remember this: when light travels from a denser medium to a rarer medium, beyond a particular angle, instead of passing through or refracting, it will reflect. Okay, it's called total internal reflection. 1 minute, I'll explain that to you. We should have had this one. Okay, we should have had props to show you. So the interesting thing is, is it okay if I show you a video of it so that you understand? Because the thing is, those even simple, in a very simple way also we can do this. Let me try. It's not reflecting. What is happening? It's reflecting inside the water and the glass. So the very interesting thing is, at a particular angle, this is not there in your syllabus or here, but if I don't tell you this, you'll always have a question as to that one, how the water inside it's reflecting. There is a process called total internal reflection. So beyond a particular angle, provided my light is traveling from denser to a rarer medium, the light will reflect back instead of refracting or passing through. Simple? Okay, everything is simple, but you should remember. Okay, so with this I think we can wind up today's, but and then we can be done in the next class also. We can be done with the rest of this chapter very easily. So what will happen? I'll go a little off topic. I'll tell you something very interesting. Are you okay? Yeah. So now one very interesting thing is, see, before you remember, if you wanted to talk to your grandfather or some relative who is abroad, maybe when you were very small, was it an immediate call? Were you able to call and hear him immediately? Maybe you guys were, because you were not of my age. When we were small, the way they would transmit voice is through copper wires, okay, electrical signals. Just remember that, electrical signal. So the thing is, if I say hello, it will take 2 seconds for him to hear my hello. Till then he would have asked, how are you? And I would have asked him another question, and there is a delay, okay, because it is from electricity. Okay, and then people realize this is not fast enough. Okay, it's quite slow. So we should do something which is very fast. So what they thought, we will use light to transmit the signal. Okay, so what they will do is, they thought, okay, Flying Show's voice will take her here, the audio, we'll convert it into electrical signals, and we'll take some laser or light, we'll manipulate it in a way, and we'll send it to his grandfather or somebody who is far, far away. Okay, but now how do you send light till there? Let's say I'm in India and my grandfather is in US. I want to talk to him. Okay, here they'll take my audio, they'll manipulate it, they'll manipulate the light. How will they send light from here to USA? It's a big question. It is a problem. Light will not go like this around the earth to USA. I cannot send light from my terrace like this and you will hold something somewhere. It's not going to work, right? So what they did was this thought, light has a very interesting property called total internal reflection. So they said, do something very smart. We'll take a wire, okay, and I'm going to take this wire, and inside this wire I'm going to make it out of a glass. This glass is denser medium, its refractive index is high, okay, and I'm going to surround this wire with one layer which is a rarer medium, refractive index is low. And now I will take the light, I'll take the light from Flanish's voice, and I'm going to send it at one angle, and then what will happen is this light, instead of passing through, it will be totally internally reflected back like this. Understood? Are you understanding this? Because it is going from denser to rarer medium beyond a particular angle. They have not covered this in your syllabus, but you should understand this. So the light is reflected back. Here also, same thing, denser to rarer medium. Will it be able to pass through? It cannot pass through, it will reflect. So the light will keep on reflecting inside this tube. So now I'll make the tube, and can I pass a wire from here to USA? Yes, I can do that. So whatever I speak on it, it will pass through light in these tiny wires around the world. And that is how all of our communication works. Your Wi-Fi is coming from that. Your internet is coming from that. Have you heard about fiber? They tell fiber internet will come, fiber internet. Have you heard that word fiber internet somewhere? Fiber, geofiber, they call it. This is that fiber, it's called a fiber. And it is very fast because it's traveling at the speed of light. Okay, is that much clear to you? Did you understand things? Did you learn something new? Okay, there's a very small portion of this which is remaining, which we can finish in the next class for sure. It is just an extension of these discussions. Maybe in the next class, within a good 15 minutes, we should be able to do this, finish this, and then we will see what to do. If you want to revise, we can revise and always go back and look at things, or we can look at the new one, or we can do a test. Okay, you are not added in that WhatsApp group, no? Both of the girls are not there, I think. Can you add them or something? You have the contact of the other girl? Do you have the contact of another girl, Princey? Do you have a contact number? Or I'll let them know, they will tell you, inform you guys. We have a WhatsApp group in which you and Princey have not been added, I think. So any discussions you do there, you guys will not know, right? So I'll tell to the reception people, they'll send you the message if there's a test or if there's an assignment. But please read through these things. It's very easy to understand when I'm teaching. It is very easy to forget. Okay? Otherwise, you guys will hear you will not. Next class, you'll be like, what was that, sir? What is this, sir? That time I'll be like, did I really teach this or did I not teach? Okay? I think with this we can end the class. Okay, take care. Any doubts? You have doubts? Tell me. No. Because it doesn't work that way. This was a very interesting, so this, if I can go into the detail of this, it's not in a syllabus. So what happens is, I take a denser medium. It's not in a syllabus, okay? You cannot blame me for wasting time because you have told me, you have asked me the question. If I take a denser to rarer medium, this is the normal, okay? As I pass light from here, it will move like this, correct, no? It's moving away from the normal. Denser to rarer, it's moving away from the normal. That much you doubt me, man. Okay. Okay, correct, no? Yeah. Okay. So this is my angle theta. Okay. I'll make this angle slightly bigger. I'll put light at this angle. Okay. Now it will move even more away from the normal. Okay. Theta 1, this is theta naught. Theta 1 is greater than theta naught. Okay. Simple. And this will also follow the same R1, R2, or I'll call this R0, R1. Sorry, it's R0 is greater than R1, R here. It's ulta. Why it's following this? Last class we did sine. Actually, it is Snell's law. This is out of your syllabus, man. But sine theta. Okay, this is called Snell's law, not required for you. Following this equation, it will do that. It will follow this behavior. But eventually, what will happen is, if I increase this angle beyond this at a particular point called when it's at R3, this will pass through here. Okay, this is called critical angle. Critical angle, because here it is not coming out of the medium, it is passing along the edge. So this angle theta 3 is called critical angle, is equal to theta critical, theta c. Any angle which is bigger than critical angle, light will reflect. Okay, this is called this is a total internal reflection. Any doubts? But if you do that for rarer to denser medium ka case, it becomes ulta, because this is from I make this one, it comes closer to the normal, right? So let's say it's coming this much. Let's just say I bring it more, it will end at the normal. That kind of an action does not happen anymore. But if I go beyond and I pass it over here, it will pass through. The moment I go to the other side, I have already done denser to rarer, and it will be total internally reflected back. Okay? Fine. I like your question. This was fun. Okay? Okay, we'll end the class. You may leave. Yes, any doubts? You think about it. Yeah. Guys who are online, any doubt? Hello? Is everything clear?
Yes, sir.
What did I talk about?
Sir, I talked about the chapter of human eye, and then whenever it goes to this and how it acts. So, but I have a doubt, sir.
Yeah. What? Okay, so the thing is, bro, it's like there are two types of mediums. One is a denser medium, one is a rarer medium. Meaning, denser means something which is thicker, okay, more dense, like oil. Oil is it's thicker than water, no? Can you hear me? Can you hear me now? Hello? Hello? Is it better? Yeah. So, if you take oil, for example, oil is thicker than water, right? And water is thicker than air, correct? So, there what we call is, we call water to be a denser medium and we call air to be rarer medium, okay? Means it is less thick. Rarer means it is less thick, it is less dense. Denser means it is more dense or it is thicker. So there are two mediums. Okay, when I pass light from rarer to denser medium, means I can pass light from air to water or air to oil, things like that. Are you able to understand now? Okay, like when you are wearing glasses, no? Light is passing from air to your glasses, right? Your glasses it's a denser medium than air. Are you clear? Hello? Yeah, are you clear? Okay, if you have any doubts, you just note them down. We'll discuss in the next class. Is that okay?